Okay, so I've got a question here. Got particle A rested on a table via a pulley system, and it's connected to another particle B which weighs 4 kilograms, or mass of 4 kilograms. The mass of particle A we don't know. Now, particle B is 6 meters above the ground and accelerating at 7 meters per second squared. So we want to find the mass of particle A. So first of all, let's draw a forces diagram and see what's going on. So we've got our table there, box A or particle A, that's there, connected to our pulley system, something like that, and tension in the ropes will be pulling along on this rope here. And we've got box B or particle B, this one is mass 4 kilograms. And what we do know is that this particle here is 6 meters above the ground. So if I just draw in my ground there, and we know that this distance is 6 meters. Okay, now the acceleration as it heads to the ground is 7 meters per second squared. So acceleration equals 7 meters per second squared. Okay, now the tension in these ropes is going to be acting in these kind of directions. So that's what we want. The boxes are pulling on the ropes and this one's pulling on the ropes as well. Now we need to assume that the table is smooth and flat and all of the tension in the ropes is taut. So that's what we need first. Now to solve this, we can use Newton's law of motion, which is force equals mass times acceleration. That's what we're going to be using here. So how are we going to solve and try and find the mass of the box? That's part A. So what we need to do first of all is resolve the forces in the horizontal and the vertical. So resolving, well, as this box is going in this direction, we can resolve in the forces going this way. So basically the tension in the rope will be pulling against in the opposite direction of the mass of the box. So we'll have the mass of the box, so force will equal the mass of the box, which we don't know, which I'm just going to put A, and multiply that by the acceleration, which is 7. Okay, so force equals 7A. Now the force is the tension in the ropes. So we can change this to tension equals 7A. Now we need to resolve vertically downwards. So that's in the correct way for the acceleration. So the acceleration here is going to be positive. So what we have here, we have the force of this will be the tension in the ropes subtracted from the weight of the box, because the tension will be pulling on the ropes here. So we're going to have 4 times G, which is our gravitational constant, which is 9.8. Let's just make a note of that. G equals 9.8. And that's going to be subtracted from the tension in the ropes. And that's going to be equal to 7 times the mass of this box, which is 4. So it's going to be 4 times 7. Okay, so as G has a value, we can solve for T inside here. So if G equals 9.8, 4 of those is 39.2 minus T equals 28. And then solve for T, and then we can plug that into here and get A. So we'll have 39.2 minus 28 equals T. So T is 11.2. So that's what we have. So if T equals 11.2, we've got 11.2 equals 7A by this value here, this equation here. So A equals 11.2 divided by 7, which is going to give me 1.6. 7, 6, 42 plus 7, yeah, 1.6. So the mass of box A is 1.6 kilograms. So 1.6 kilograms. So that's what we've got there for our mass of box A. Now what we want to know is the speed of B when it hits the ground. So it's accelerating down at 7 meters per second squared. Now we know it travels 6 meters, so we've got the distance, we've got the acceleration, we need to know the speed. So this is going to be a SUVAT question. So if I put my values that I know in SUVAT, speed it takes, so we want the velocity, so that's what we want. Acceleration we know is 7. Time we're going to come to in a moment, that's being this question. Our initial velocity is going to be 0, because it starts from stationary, and the distance travelled is going to be 6. So the equation we've got with SU, V and A is V squared equals U squared plus 2AS. So we can make use of that and then solve for V squared, because we've got all the other variables. So V squared equals U squared, which is 0, plus 2 times A, which is 7, times the distance displacement is 6. So that's 42 times 2 is 84. So V squared equals 84. So V equals the square root of 84, which is just a little bit over 9. So just a bit more than 9. So I'm going to leave that in its exact form, or I could put that as 2 root 21 if you want to go for surds. So now the time taken for B to fall to the ground. Now I now know my velocity, which is square root of 84 or 2 root 21. I'm going to write 2 root 21. I now need T. So here I've got T I need to use, I've got my A I need to use, and I've got my displacement to use and my velocity. So I've also got my initial velocity here as well. So I can use a couple of different equations here. So for part C, for the time it takes to hit the ground, I'm going to use this one. I'm going to use S equals UT plus a half of AT squared. So let's keep these ones separate. So now, as we did before, let's plug them into here. So I've got 6. My initial velocity is 0, so that can just disappear. And a half times acceleration times time squared. So half times 7 times time squared. So therefore 6 equals 7 over 2 t squared. So therefore now I've got 6 over 3.5 to get t squared on its own, which I can now say 12 over 7. So t squared equals 12 over 7. So therefore t is the square root of 12 over 7. So 12 over 7. And that's all enclosed in the square root. Let's just put that down there a little bit further so we can just make that clear. T equals square root of 12 over 7, and that is in seconds. And here my velocity, 2 root 21, that's meters per second. So that would complete my answers. So time is root 12 over 7, you put that in a calculator. My velocity as it hits the ground is 2 root 21 meters per second, and the mass of box A is 1.6 kilograms. Okay.